Erik Darling here with Darling Data. Look how happy we all are. Look how thrilled everyone is to be here. It's a grand day, isn't it? Today's video we are going to continue talking about our good friend, our Lord and Savior, the store procedure. In this video we're going to talk about the use of transactions in store procedures, what they're good for, what they're not good for, and sort of what people think that a transaction may guarantee that it definitely does not guarantee. So we have that to look forward to. But of course, before we dive into those titillating, exhilarating topics, let's talk a little bit about your money and me. If you would like to support this channel and the wonderful content that I create, you can sign up for a membership down there in the video description. It's the link that says become a member. And you can, for as little as $4 a month, support a starving consultant. If you enjoy this channel, but you just for some reason cannot scrape together $4 a month, you can like, you can comment, you can subscribe. And if you would like to participate in the grandness that is me answering office hours questions, this link is also, I'm going to pretend that I'm grabbing it and throwing it down in the video description. This link is available also in the video description. You can click on that and submit your question. And if you're at all curious about if you maybe made some typos or you want to fix something, you can edit your question after you submit it and make sure and do some like proofreading on it. I would highly suggest that you all do that because some of the questions that come in are a bit malformed. If you need help beyond what is available here on YouTube or what you can do on your own, I am available to help as a consultant. I am a SQL Server consulting partner. And I can do all sorts of wonderful things for you and your server. Health checks, performance analysis, hands-on tuning, responding to performance emergencies, and training your developers so that the performance emergencies stop happening. Wonderful set of gifts I have that I wish to give to you in exchange for money at a very reasonable rate. If you would like some training on SQL Server, just to maybe watch some videos, get a little bit better, a little smarter on your own, you can get all 24 plus hours of mine for about 150 USD once you apply the coupon code at checkout. It will magically reduce the cost of your training, and that training will be available to you for life. Lucky you. SQL Saturday 2025 coming at you. Live and in person on May the 10th, 2025 in New York City. SQL Saturday. It's a Saturday, the 10th. And of course, May the 9th, we have a full day performance tuning pre-con with the lovely, talented, fabulous Andreas Volta. So you'll have a wonderful time with that. And with that out of the way, let's talk about these transaction things here. No, we need to go to SSMS for this. Now, transaction and error handling usually go together sort of hand in glove. The ebb and flow of the last few videos have been around error and situation handling, batching, retrying logic, and stuff like that, right? So all stuff that kind of, and debugging, all stuff that kind of ties in together when you're trying to make a really robust solution for something in SQL Server. It doesn't matter. So like a lot of store procedures are like not just like running a query, they're like building a process to do something in SQL Server. So what you end up with is like these store procedures that have to like do a lot of stuff that maybe store procedures don't always have to do, right? Like again, like retrying stuff, self-healing, debugging, logging, making sure that if something messes up, you're able to get your data back into a normal state. So like all these things tie in together when it comes to building a good process in SQL Server. The main thing that you really need to understand about transactions in SQL Server are the locking ramifications and the things that they don't guarantee. So like the first thing to understand is that there is absolutely no respect for nested transactions, right? It doesn't matter how many transactions you nest, like let's just say you, like for some reason you nested 5 transactions. If you ran rollback once, all 5 would roll back, right? If you have 5 nested transactions and you need to commit them, you do have to commit 5. Like committing only decrements the transaction count by 1. You have to do 1, 2, 3, 4, 5 commits. But rollback, they all roll back, right? So the SQL Server does not do nested transactions in a meaningful way. The second thing is that the default isolation level in SQL Server, read committed, does not give you a snapshot point-in-time view of your data, and it does not, like aside from applying locking hints, like with a select query or like doing something else that locks people out of whatever data you're touching, or using something like spget applock to lock people out of the code that you're using to serialize access to that. Like you can't really, like with recommitted, you don't get a snapshot view of the data, so you have to really think carefully about like how data flows in your transaction, right? Like one query to the next. If you're just doing a transaction with a single query in it, there's not a lot of point because SQL Server already has auto commit transactions. So any like insert, update, or delete is already happening in the context of a transaction. Anyway, it's really having multiple queries in an explicit begin tran do something that like gives you any ability to like, acidify a group of queries. The other thing is that not everything really needs to be in a transaction. Like again, single statements don't really benefit at all from it. The lack of nested transactions has been well documented over the years, and we do have save points. It's not really the same thing. For the sort of remaining stuff in here, let's talk a little bit more about like what happens during a transaction specifically. Now, blocking is probably the biggest thing that transactions will cause on your server. So like unless your transactions are really, really fast, you sort of just like increase your chances of having like locking and deadlocking problems. You also, like you have multiple queries in a transaction, it can make the block process and deadlock XML reports really confusing, right? Because you see like multiple queries in them. If there's like triggers involved or anything else weird, like you just make it a lot harder to sort of unravel exactly what happened in them. So like just be careful with that. Remember that under read committed, the default crappy isolation level in SQL Server, read queries can block and be blocked by modification queries, and read queries can also deadlock with modification queries. Specific plan shapes and stuff will do that. So like make sure that when you're using a transaction, make sure that when you're using explicit transactions, make sure that it's absolutely necessary for you to do it because, like either from an error handling or like a consistency perspective, stuff like that. Because if you don't need it, don't do it to yourself. Because if any one of those queries, like let's say like you have like 2 updates run and they're really fast, right? And then you have a delete run, but that delete takes like, I don't know, 5 seconds. Let's say you don't have a good supporting index for that delete. The locks that those 2 updates that were really fast took are going to hang on until that delete finishes. So you don't just have 2 quick updates that like do something and get out. You have 2 quick updates that are now beholden to this delete that takes 5 seconds, right? So you just like increase the surface area of your query in duration, and the bigger that surface area gets, the worse your problems get, because like as this query overlaps with other queries trying to do stuff, like all those surface areas line up in a way that either like exacerbate locking problems or lead to deadlocks, just because like you had some updates over here and delete 5 seconds here, and then something else wants to do something over here, and like you just end up clashing with like the updates or something. Like those locks hold on and start interacting with other queries, and you end up with a problem, not just for like one of the updates, like all 3 queries in that transaction now have a problem, because when they deadlock, it'll roll back. So just be really careful with that. Make sure that you use appropriate locking hints to make sure that you preserve data integrity if you're like reading data to modify it later. And make sure that you are handling errors, rollbacks, and commits appropriately here. And make sure that you have tuned everything to happen in that user transaction as much as possible. Because everything you do between like begin transaction and commit, or like whatever rollback happens, those locks have to hold on until that thing makes a decision, right? Like you can't like just say like within a transaction like and release the locks now. Like it just doesn't happen that way. So just be really careful with all that stuff. Now, you also have to be really careful to understand how isolation levels work in the context of transactions. Not just read committed. I know most of you out there are just so desperate to get away from read committed that you're using no lock or read uncommitted. But if you're using optimistic isolation levels, whether it's read committed snapshot isolation or snapshot isolation, both of those behave somewhat differently in the context of transactions too. I cover that in my video series, Everything You Know About Isolation Levels is Wrong. There's a section on read committed snapshot. There's a video about read committed snapshot isolation versus snapshot isolation, where if you have questions about that, you should go watch that one, because there's a lot of good information in there. But like, let's say you're doing something like this, right? Where, like, granted, not my favorite thing in the world, declaring a local variable and setting that local variable equal to a value here. In this query, we're looking for the ID of a user in the users table who has like reputation has not gone above 1, but has a post, right? Let's say they have a post. They've asked a question, but that question has a score of 0, right? No one voted on it. Poor thing, you poor dear. And we want to give you a mercy vote, give you a pity vote. You might, of course, if you might bail out if like no one meets that qualification. So like, let's say user to promote is still null. You might just say, no, we're out of here, right? We're done, return, stop doing work. But then you go and do this, and you go and find like a post to update based on who that user was, and you update and you bump that score up to +1, right? Just add a 1 to that score. Under read committed, unless you take out locking hints like here and here and here, you could end up with some weird stuff happening. Leaving aside the obvious stuff like local variables, which no self-respecting performance tuner would ever do, right? Like this thing in here. You get whoever that first user is, you only get like their most recently committed data first, right? Again, you're not locking that data so that it can't change between when you get that data and when you do something with that data. And also, you don't do anything to ensure that nothing changes between when you get that data and like when you do something with the data, right? So like data can change around you up here because there's no locking happening in the select query, right? SQL Server does not have a select for update. You have to add in locking hints in the from clause, like updlock serializable, whatever you need to happen to prevent changes to that data. And that leaves you wide open to like data changing around you, right? Data can just change under concurrency. With that, what you could end up with, you can end up with something as wild as like that user could delete their profile, right? They could say, I hate this site. No one ever upvotes my questions or answers. It's terrible. Everyone just makes fun of me and downvotes me. They could just get sick of Stack Overflow and be like, I'm out of here. Someone could go and go vote on their question after they're like someone comes along and they're like, wow, this is a great question. Upvote. Now all of a sudden that question has an upvote and it no longer would qualify for what our query is doing. They could also go and delete their question, right? They could say, you know what? I understand why no one upvoted this. Now that I read it, I realize I was being stupid. I opt myself. I was being a foolish, I was being a silly little ninny. Ah, delete this question, right? So like nothing protects that data after you've read it and before you update it, do anything with it. So like the transaction doesn't do that unless you take out specific locking hints. Read committed for like the billionth time is not a snapshot consistent view of your data during a transaction. If you were using snapshot isolation or read committed snapshot, or rather, if you were using snapshot isolation, it would be. If you were using read committed snapshot isolation, it would be a lot closer to it. But like read committed, the default pessimistic isolation level doesn't give you that. All read committed guarantees is that the moment you read data, that's the way it was committed in the table. And it's very, very flimsy if you think about it, or if you watch my series on isolation levels where I explain all of this stuff in great detail. So if you want those changes, if you want to avoid those changes, you would need to add in the updelock and serializable hints to your select query and like the exist subquery and like basically any select before you do like modifications. Even if you were to do all that work in a single query rather than two queries, you could run into the exact same issues without locking hints to protect the data that you're reading, right? It's like read committed locks do not hold on, right? They happen very quickly and then they let go, right? So just be very careful with that stuff. So like everything in SQL Server, like whether you specify a cursor or not, kind of under the covers is cursor driven anyway. But once those read cursors find the rows that they care about, anything goes like until like exclusive locks start being taken, like anything else can come along and be like, well, like I got it now, sucker, right? So some more pseudocode, this is a pattern that I've noticed in more than a few clients now, is they do something like this, right? Where we're going to do an insert into a table, right? We're going to find some user stuff and we're going to cross apply some stuff. And then, but what we want to do is avoid redoing data. Like we don't want to reinsert any rows, right? So like this is sort of like a broken up merge, right? Sort of like, don't get me started on merge for various reasons, but let's just say that like if you had a merge that was doing an insert/update action or any merge statement with multiple actions, you need serializable hints on stuff. But like let's just say you're doing this where you're going to insert any new data, right? Any posts that don't exist, you're going to insert those. And then I don't know how that parenthesis ended up there, but whatever. And then for any new data, you were going to just do an update, right? All sorts of weird stuff can happen in here because you are doing reads from multiple tables where, again, under read committed, even in a transaction, data can change all around you and you can run into all sorts of strange stuff, especially, if you're not locking data out here, right? If you're not preventing changes to this stuff, you can end up with weird race condition stuff in queries like this. This update is fairly safe, except we are just doing a read from here, right? So there's a lot for you to think about. The idea of the code is to insert any new users into the high question score table. Let's just say that there's another query that might come along and update the high score for existing users. The problem becomes fairly obvious, right? Especially under concurrency. There's absolutely no reason to roll back new users inserted into the table just because the update query fails for some reason. Let's say that the badges table was recently modified to accommodate some new longer badge name, but the high question scores table wasn't. We got a truncation error. That thing fails, something weird happens, right? But that truncation error shouldn't invalidate the new users that got inserted. Likewise, let's just say that if our invisible score updating query produced a bigger integer than that's an integer column. Let's say some like really awesome question came along and all of a sudden you had a query that was a question that had like 2 billion points, with 2.2 billion points that would be bigger than an integer. Now you're now in big int territory. You would also get an error there. So you just have to be very careful with all this stuff. Transactions should really only encapsulate queries where correctness, like data correctness, would be affected by one of them failing. Do I have the right affected in there? Let's just do that. Just so we don't have to figure anything out on the fly. Just something would happen to it. You have to be very careful when you're using transactions to A, make sure that you need them. B, make sure that they are as fast as possible. C, make sure that you're doing the right thing as far as rolling back, error handling, all that stuff. And also make sure that like the queries that you're grouping together, go together to form the Voltron of result correctness for the whole set of them. If you don't need queries to ride or die together, they don't need to be in a transaction together. So be very careful with transactions. Like I said, you can end up with just exacerbating any locking and deadlocking problems that you have in your system, and they can also make the blocking and deadlock XML reports very, very confusing to look at and read through and figure out what happened. Various other things like triggers and barring keys can make life even more difficult, but that stuff is also intra-transactional stuff where triggers are like an implicit transaction, foreign keys, those especially with cascading actions, those promote to serializable. You just end up with lots of weird problems. So be very careful when you're using explicit transactions, because if you start just mindlessly wrapping entire store procedures or queries that just don't need to be in a transaction together in them, you can end up with some really painful problems. So thank you for watching. I hope you enjoyed yourselves. I hope you learned something, and I will see you in the next video, which will be just as pertinent to store procedures as the rest of these have been. So I look forward to speaking more about that. Anyway, I'm out of here. Goodbye.